Hello everyone, welcome to the 19th edition of the iChemE Safety Lore. During this webinar we will be focusing on confined space entry, which is a rather interesting topic considering it's required within multiple industries throughout the world. Within the webinar we will discuss two incidents that have occurred in significantly different industries which still require the same safety measures to be in place. Before we move on, I'd just like to say that the ISC's purpose is that we assist organisations from industry, government and universities focusing on high hazard activities to improve their process safety performance. We do this by achieving best practices and resources through podcasts, ISC publications, webinars and safety law documents. We also provide a unique opportunity to enhance process safety performance through training via our internationally renowned facilitated case studies and process safety leadership and culture programme. Here is a list of just showing the images of the companies that are our operating and industry partners. And we've got a wide range that is continuing to grow, from water companies, energy companies and air services. So we're getting a broad reach with our knowledge. The Safety Centre also has a large number of supporting partners and collaborators. In front of you can see the images of the universities and collaborators that we have. So on to what is a confined space? A space which is large enough for someone to enter and work. Enclosed or partially enclosed space. Has a restricted entry or exit routes. A space which is not designed or intended to be primarily used for human occupancy. Contains or has the potential to contain a hazardous atmosphere. Moving on to case one, it's a chemical plant nitrogen asphyxiation. On the 27th of March 1998, a staff member, we'll call him Worker A, was killed and a contract worker seriously injured due to asphyxiation from nitrogen exposure while completing an unplanned internal blacklight inspection of a 40-inch pipeline. As the work party begun the inspection, they needed to block out the natural daylight that was occurring. The work party had asked two nearby contractors who weren't in the original work party to assist them by holding a black plastic sheet in place during their daytime inspection. The process plant at the time had two uncoordinated activities taking place: the blacklight inspection and replacement of the oxygen feed mixer. Worker A had assisted in the catalyst replacement job the day prior to carrying out the inspection and instructed N2 to be injected to protect a new catalyst reactor from moisture buildup that had been installed. Worker A required a nitrogen flow path. Worker A required a N2 flow path to be in place and open bypass valves on the reactor discharge line, allowing nitrogen to flow into the rest of the process, including the north end of the pipe where the inspection would take place the following day. So ultimately, the Worker A was involved in two different activities at the same plant, was trying to prevent a problem in one job by allowing N2 to be used, but didn't connect the dots to realise that he was actually creating an issue somewhere else, which was a job he would be working on the following day. Some key findings is that the investigation found the blacklight inspection was not planned or scheduled to take place, and it was only a visual inspection of the flange faces that was required. There was a lack of leadership, communications, planning and personal direction with those working on the plant and equipment, which resulted in no preparations occurring for a confined space entry, which this task ultimately was, as two people were internal to the pipeline and then a cover was then put over it. There was no consideration for simultaneous operations, as two work parties were on a connecting process at the same time, which was the pipeline work array had put nitrogen into the day before. Additionally, we see that there may be a possible culture issue, as it was also noted that earlier in the day, other contractors were instructed to clean the flange faces and had been exposed to high concentrations of nitrogen. And the reason they were exposed was the flange faces had clear bags over them to protect the face. The workers have gone along to the work site, removed the clear bags, and were exposed to the nitrogen, but the incident was not reported, and there was no health concerns as the weather was high winds at the time, so this had naturally blown away the nitrogen. So the contractors at that time didn't believe there was anything worth reporting. If they had done so, we might have been able to highlight that there was an issue with the pipeline prior to the inspection taking place. There was a lack of safety management through no formal isolations. There was no signs, no barriers, and there was no atmospheric testing in place. The full work site for case one was not prepared, nor was the management for a confined space entry. Moving on to case two, this is a completely different industry. Here we are in, we've gone from a chemical plant to now a fishing trawler. So on the 14th of August 2018, a second engineer on board a trawler collapsed while inside a refrigerated seawater tank while attempting to manually sweep residual seawater into a bilge well in preparation for maintenance work on a heat exchanger. Freon gas, which is 4 times heavier than air, had leaked from known corroded tubulars within the heat exchanger into the refrigerated seawater tank. 3 colleagues attempted to rescue the individual before suffering breathing difficulties, which then resulted in another 2 colleagues donning breathing apparatus to perform an emergency rescue. The individual entered the tank on his own accord with no safety precautions typically associated with a confined space activity in place. The refrigeration plant had undergone historical maintenance in January 2018 due to the leaks within the system where tubulars had been plugged. Some key findings during the investigation was in January 2018, it was noted that the heat exchanger tubulars were beginning to fail as corrective maintenance was carried out, resulting in corroded, leaking tubulars being plugged. There was no management of change in place for this, nor was there an adequate risk assessment, something that ultimately the design of the heat exchanger was getting changed as we were plugging tubulars. There was no risk assessment to see if that was still a suitable heat exchanger for the requirements of the vessel, nor was it documented so that in future all workers would be up to speed with the state of it internally. There was no safe system of work or any up-to-date procedures on board the trawler, with investigations highlighting the last update to the risk assessment was 11th of September 2000. So that's 18 years since the risk assessment was updated on this trawler. There was also no atmospheric monitoring equipment on board. There was no rescue procedures. There was no rescue equipment at all. There was no positive isolation in place and no risk assessment for the confined space entry. There was a valve closed, so the workforce believed they had isolated it, but the valve was later found to be passing as it was designed to be watertight and not gas tight. The investigation found that the absence of appropriate safety measures had become normalised on board. So it's 2 very, very similar incidents we have here where we've got a chemical plant and a trawler. You wouldn't really ever connect these 2 industries at all, but here we are with confined space entries, and leading to fatalities, and it's the exact same fundamentals that should have been in place for them. Moving on to lessons for management. Here we've got a list of some of the key findings and learning points for them, but I'd just like to pick out a couple of key ones for myself, which is ensure that safe work systems such as a permit to work, a lockout tag out, and atmospheric monitoring systems are in place and followed. Ensure that there are written procedures on the requirements to be in place for confined space entry, including the requirements for atmospheric testing, are understood and complied with by all involved. Ensure that changes to scope are adequately assessed and approved prior to work taking place. Have in place an effective management of change process to adequately record changes from normal operations. Ensure risk assessments are reviewed and updated at adequate time intervals to reflect current conditions. So I believe these are some of the key points for management to ensure that are in place when such a high profile task is taking place. Moving on to the lessons for engineers and supervisors. Here we have a list of some of the key findings and key improvement points, but I'd like to highlight some which are: ensure all isolations are fully documented and perform a line walk to verify all isolations are correct. Have daily or shift briefs to ensure site teams are aware of ongoing work scopes, simultaneous operations, and effective barriers are in place. When issuing a permit to work, ensure all hazards specific to the task are identified and that controls are implemented to manage these hazards. Ensure all those involved in the task are familiar with the hazards and controls. Perform regular checks of the work site to ensure controls are in place and working. So here I feel that the engineers and supervisors are the first layer of management that is potentially a boots on the ground. So let's make sure that you've carried out a verification check on the isolation, ultimately a second check over your frontline worker. Make sure you're happy with that your team is fully up to date with the plant, the operations, and the tasks for the day or the week. Make sure that your team is fully up to speed with the specific hazards and the controls and mitigations that you need to ensure safety is paramount for everyone involved. And then a key one is, perform the regular checks to ensure that these controls are in place and working. So we need to just, be visible, be seen, be out there, and carry out a baseline audit process on the work sites. And have that conversation with the people carrying out the jobs is a thing that can get undervalued sometimes. Moving on to lessons for operators. So there's all of these points are quite key. So the operator is the boots in the ground, actively going to the work site. He's involved in the isolation, the preparations, and the release to the contractors or the maintenance teams. So the operator should ensure that all plant is safely isolated as required by permit to work systems and perform daily or shift checks to ensure that the integrity of the isolation is sound. Ensure that drain, flush, purge and vent operations are completed prior to releasing work site for site entry. And that's for all activities that involve breaking containment. So we need to ensure that the integrity of the isolation is sound, and then that the inventory of the pipeline is clear, and that we have a breathable atmosphere prior to releasing. Ensure all atmospheric monitoring is completed as required by the permit to work systems. Perform regular plant checks on all work to ensure it is being performed as required and following the permit to work controls. Stop the job and report any deviation from the permit to work system, including additional members of the work party. Ensure sufficient handovers are in use, documenting all activities. ensure emergency response equipment is on site. So the operators get quite a key role to ensure that we want to enhance the communications across shifts so we know where we are with each task. The operator can be on site. He knows who should be in the initial confined space entry work party. If anyone else comes in, it should be the lead of the team doing the confined space entry to stop the job and have a discussion with them on the risks and controls in place. But the operator can also play a vital role in doing safety checks within his area, having the conversations with the team doing the confined space entry, and ensuring that they're up to speed and they know the risks, hazards, and the controls and mitigations that they need to have in place. So moving on to a quote from Dame Judith Hackett, which I feel is a quote that is extremely relevant with these two case studies here, where case one's a chemical plant, case two is a trawler. They're actually close to 20 years apart, very similar failings. And as the quote says, there are no new accidents, just different people making the same mistakes because of a failure to recognise the relevance to them of other people's experience and therefore not learning. So if either one of these industries pick up one thing from another, we may have been able to prevent even one fatality occurring. So I'm quite happy to take some questions for those that are in the webinar. Please feel free to add them into the chat box. Also, if you don't want to ask them here, I've provided the email for the Safety Centre, myself and also Trish Kerrin, the director. And you can see that we've got social media channels that you can also reach out to us on. So I'd like to open the floor for any questions.
Thanks, Craig. For everybody online, it's Trish Kerrin here. That was a really interesting presentation, and one of the things that that I always remembered from dealing with confined spaces when I was the safety manager at a facility was a focus on absolutely the verification check of all isolations. And so we had a process where a senior member of the management team had to do a physical inspection of all isolations each day to make sure that they hadn't changed if the job was going on over a series of days. And it was actually something we took very, very seriously. So I would go out and personally do the verification checks myself. And one of the other parts we had in terms of not only looking at verifying physically all the isolations are still in place, but we also focused on asking 3 specific questions every time we verified a permit, either a hot work or a confined space permit. And those 3 questions were, do we need to do this work now? Do we need to do this work here? And do we need to do this work this way? So from a confined space perspective, it could be, is there a better time to be doing that entry because there's other things going on? So do we need to do it now? Do we need to do it inside the vessel? Do we need to do it right here? Or could we do it elsewhere? And do we need to do it in the way that we were planning? Could we create a safer way to do it? And I've always kept those key things in the back of my mind of, do we need to do it now? Do we need to do it here? Do we need to do it this way? As a good test. I'm sure you've probably seen sort of similar things in some of your experience as well.
Yeah, I think that's key. What you've said is, it's how can we remove the individual having to go into this vessel? Can we work smarter to get the task done? I mean, we're even seeing it into the renewable sector that's occurring now as well, where the blades of a wind turbine, for example, need to be inspected. So they're now scaling back and humans going into these blades to inspect them, and we're seeing a lot of drone techniques getting used. So as technologies are advancing, we are starting to see improvements where we can remove the human from it, ultimately making it safer for us all. But that doesn't take away from the fact that if we still have the issue of, before you open the door to a vessel, you still have to ensure that your isolation is in place and sound, as you said, and check it. and that the drain, flush, purge and vent techniques are completed before we can even open or break containment, exposing anyone to these chemicals. So yeah, I think there's some key points to pick up on, and from my experience, it's more we need to positively isolate this before you would even consider releasing this to anyone. An effective lockout tag process has to be in place, and it has to all be documented in front of the supervisor, and you need to prove that you've done an atmospheric test and that it's clear before we could even consider releasing the work site from the operator to the maintenance teams. Documentation, communication, these are all very vital points in ensuring the safety of everyone involved.
Yeah, absolutely. One of the other things that I always remember from very early in my career was I was told by a wise depot manager, if it's not written down, it never happened. You have to document what you're doing. If there's no documentation, then you can't assume it's in place if it was never documented. You still need to make sure people aren't documenting and not doing the work, but you know, there's you need that evidence that it was done.
Yeah, and that's stuff that we find in these two incidents that just wasn't there, even to the point where the trawler never had an updated risk assessment for 18 years. So these are quite frightening that we, you know, and it was relatively recent. That was it was 4 years ago. So yeah, we need to keep promoting and trying to enhance the communication aspect and documentation for confined space entries.
Absolutely. Okay, well, we have one question that has come in, so let me just ask you that question. Can you please explain the requirements of ventilation of confined spaces?
The requirements, so ultimately we would have to ensure that, so I'll just go through the full process of making the site good. So you would drain your inventory, you would flush it, likely with a potable water if required, or if it was a gas, you wouldn't flush. Then we would purge it with a nitrogen, and then once the toxic gases are gone, we would have the system venting. Once it's venting, that would allow us to ensure that all toxic gas is gone and there's sufficient oxygen in there for a human to survive. The venting process is ultimately at the end where we've drained it, we've flushed it, we've purged it, and we've vented. So all toxic gases are gone, and at that point we should be left with an environment in the confined space that is sufficient for a human to survive.
So in some instances as well, you might then need to use some forced air movement depending on the situation that you're in potentially, as well as that ongoing atmospheric monitoring as well, to make sure you know precisely what the atmosphere is within that confined space, especially if the work going on in there could liberate some contaminants in some way.
Yes, so my experience, I remember when I was younger and I was an apprentice, I had to go into a drilling mud tank. There was work to get done, so regardless, we didn't know if the tank itself was ever going to be oxygen or free of toxic gases. So because there was still some sludge at the bottom that had to be dug out. So what we actually had to do was clean the tank as best as possible from the outside, and then I had to enter it under a BA and kick up and mix up all the mud just to check for toxic gases, because originally the gas meter was saying, 90% of the way down the ladder into the tank was oxygen fine, but as soon as you disturb any residual sludge, we can call it, that was in the tank, there's potential for that to release a toxic gas which could overcome someone. And if we go to the example of the trawler, you could have had your equipment in place for that, but the freon gas was the atmospheric testing equipment in place, but that freon gas was heavier than air, so you need to ensure that still when that tank was getting inspected, because of the nature of the hazardous gas you had, that you should still risk assess that you need to go in and BA and fully cover the entire tank for any gas. And as there was water in there, kick it up, make sure there's nothing trapped within it.
Yep. Okay. Thank you. And we've got one more question. Can you propose any digital initiative to prevent any incident related to confined space entry? So I guess this sort of comes down to, Craig, have you had experience with electronic permitting system? Because effectively this is the documentation required is all about controlling the permitting system, the isolation, the access and the verification details, and the entry testing. Have you seen digital permit systems that do manage that sort of area?
Yeah, so it's a good question. Obviously there's a system that holds you accountable. You still need to follow the correct steps for this. So if I was to go through a typical permit to work for controlling a confined space, the individual who's likely to perform the task would create a permit, create the risks, hazards, controls and mitigations and document them on the permit. That permit should then be taken to the operator that is likely in charge of that area or vessel. They discuss the job, perform a work site visit, as the operator is likely able to highlight some hazards that the individual doing the job might not be aware of, such as there could be hot pipes nearby the entry exit, high pressure pipelines that they're not aware of. So these are all additional hazards that the work party might not be aware of. Once they've had that discussion, they would go back and sign onto the permit. The permit would then go a level up in management to the supervisors where they would verify it. And then the overarching manager of the plant or facility should then verify the permit so it's ready to be issued. But even once a permit is in a state that we believe that all management of the plant and the operators are fully aware of the task, the hazards and the controls, we would still have another check that before a permit could get issued, the isolation would have to be on the permit, in place. We would need to include a document within the permit that highlights that we've put the isolation in place, we've checked the integrity of it, and we've set up a frequency of how we're going to inspect the integrity of the isolation. Then the supervisor who issues permits would then have a discussion with the work party themselves directly at the point of issue. And once that supervisor is happy that, atmospheric testing is complete, positive isolation is placed, the boundaries and integrity is good, then we can release the permit to work. So the permit is a good process to ensure that the workforce, the operators, the contractors are all held accountable for the controls, mitigations to be in place. But we have to ensure that that gets checked. There has to be a peer check, a management check. It needs to be audited, and we need to ensure that this is what we do, what we say we're going to do, because I've seen it many times before that, there's a confined space entry occurring. The permit says all this. You go to the website and you'll find out there's 3 people in it, but there's not enough BA bottles. There's maybe only 1 escape set on site. There's not sufficient enough equipment, or you'll go to a website and there's not enough. You don't believe there's enough people, one, to keep an eye on the people performing the task inside, one who's available to keep comms up between themselves and the control room, emergency response. It's permit to work system's great, but we need to ensure there's that balance and check in place. I hope that answers it.
Go on.
I was just saying, I hope that answers the question. It's the permit to work system. It's great to get the basics right, but that balance and check is key to moving forward and ensuring we
Yeah,
do what we
absolutely.
say we're going to do.
The system has to be followed. It can't just exist in its own right as a digital or electronic system. It has to be followed as well. Okay, that is all of the questions we have. Thank you very much to everybody for joining us today for our Safety Law number 19 webinar. On the screen, you've got a QR code. You can scan that code to go to our website where you'll see our upcoming webinars advertised. We'll recommence our webinars again in February 2023, and we've got a couple scheduled in February. So we look forward to welcoming you all to those webinars at that point in time. I wish you all a safe and happy holiday season and a very safe and prosperous new year. And we look forward to engaging with you all again next year. Thank you very much. Stay safe.